algebra students, here is your second video for review part 2 for chapter 8, pardon me. And we're going to start off with adding and subtracting, multiplying, dividing, scientific notation. Now remember that when we have two numbers like this, oops, I'm not in right mode. There we go. We have like an x to the fifth plus an x to the fourth. They are not like terms. There's nothing we can do, right? So we can't put them together. Now with scientific notation, that's true, but we're able to adjust the number so that they can become like terms. So we have 2 and 31/100 times 10 to the fourth plus 1 and 1/10 times 10 to the third. Well, right now they're not like terms. So I want to turn this 3 into a 4, which is like multiplying by 10, right? Well, over here I have to divide by 10, which causes this to become that number. So I'm actually adding 2.31 and 0.11. And note, the bases and exponents match now. I'm good to go. So I'll just add and get 2.42, sorry to write a 1 there, times 10 to the fourth power. All right. Uh, now I just have to make sure and look that my uh, coefficient, my decimal, is in the right place. I have a number between 1.00 and 9.99. If not, I might have to readjust my answer. Okay, but it looks like I'm good on that one, so let's go to number 2. Again, the exponents don't match, so I need to turn that into 2, which means I multiplied it by 10, which causes division there, which means I'm actually subtracting 8.80 times 10 to the second minus 0.44 times 10 to the second. Okay, and that's going to become a 7.36 times 10 to the second. I check to make sure my answer, my decimal is in the right place. It is. I'm good. There we go. Okay. All right. Now, multiplying and dividing scientific notation is actually easier. I'm going to multiply 8 times 9, get 72. 10 to the fourth times 10 to the sixth is 10 to the 10th. The only problem is my answer is not in scientific notation. The decimal point is here, but I need it there. To get it there, I'm going to divide by 10, turning 72 into 7 and 2/10. But if I divide that part of the number by 10, I have to multiply this part by 10, and I'm going to get 10 to the 11th. And there you go. Pretty easy stuff. All right, division. I've got to divide here. Now, I know this boggles your mind sometimes, but 36 divided by 12 is 3, right? Well, 3 and 6/10 divided by 12 is going to end up being 0.3. I'll divide here, getting 10 to the third, knowing that 5 minus 2 is 3, right? Okay, taking a look, I am not in scientific notation. I'm going to multiply this guy by 10, turning him into 3, which means I have to divide by 10 over here, and that'll turn him into 10 to the second power. All right, now by the way, just to make this answer make sense, that's 300, isn't it? 10 squared is 100 times 3, 300. That's all that answer is. Okay, come on down here to graphing some exponentials. And let me see if I can get the same color here. Remember, when we graph these, they're not going to be a line, they're going to make a curve, and there's going to be an asymptote, okay? If you were paying attention, well, I won't say it yet. Let me make a little t-table and see if I can figure out where these numbers are going to be, x and y. And let me see here. I think 3 is going to get too big. I'm going to put 2, 1, and I can do 3. I'm going to do this one the long way. You don't have to do them all this long. 3, 2, 1, 0, negative 1, negative 2, negative 3. Okay. So when I put 3 in, I'm going to get 2 to the third, 8 plus 3 is 11. So 311 actually goes off my graph, but only by a little bit, so that's okay. All right, 2 to the second is 4, plus 3 is 7, so 2 goes to 7, which is 987 right there. 2 to the first is 2, plus 3 is 5. Should be right there, 1, 5. 0, 2 to the 0 is 1, plus 3 is 4. There we go. Negative 1, 2 to the negative first is 1 half. 1 half plus 3 is 3 and a half. So negative 1, 1, 2, 3 and a half. Okay, negative 2 is going to be negative 1, is going to be 1/4. This will be 3 and 1/4. And then this one's going to be 3 and 1/8. You can probably tell where the asymptote is now. Hopefully you remember that the asymptote can be found by looking right here. There's a plus 3, and look at that. Y equals 3 is my asymptote. Now to actually graph my line, my curve, this is going to be hard to do with the airliner. I don't do it very well, but it's going to hog the asymptote. And then it's going to keep, sorry, this is very challenging to do with the airliner. Okay. Anyway, that's pretty close. Like I said, I won't grade you on your actual coordination level. I was doing pretty good till I had to shoot up there. Okay, that's a little bit better. At least I hit it. We know that it climbs vertically forever. It does not go completely vertical, right? And then horizontally, it never actually goes horizontal either. It's getting closer and closer to the asymptote, but never quite getting there. All right, now let's see if we can take what we learned from that one and apply it to this gray one here. And I'm not going to make a t-table this time. I'm going to see if I can do it. Well, first of all, I know I've got an asymptote, and I'm going to do it on the same graph. My asymptote is going to be at -1. Okay, so there's my asymptote. And so now I'm going to plot my points. I'm going to do a couple in my head. Okay, now you can use a t-table if you want. I'm just going to show you that I can use what I know. Okay, first I'm going to put 0 in. 3 to 0 is going to be 1. 1 minus 1 is going to be 0. Okay. 3 to the second is 9. Minus 1 is 8. Okay, so that's going to shoot way up here. Now some of you might be thinking, uh-oh, it's going to cross the asymptote. Well, remember that green asymptote is from the other problem. It's not really there. In fact, if it's disturbing you, I can go ahead and move it out of the problem. All right, so 3 to the first is 3 minus 1 is 2. So right there. And then if I do a -1 for x, I get a 1/3. -1 minus 1/3 is -2/3. And then if I get a -2 for 3, I'm going to get a 1/9. So it'll be 8, actually 2/3 would be down here more, wouldn't it? And you see it's going to do something very similar to the previous one. I'm drawing very slowly. Okay. And then, of course, it's going to come along here and hug. There we go. And that one looks a little bit better. It's still not perfect. I can do it better with pencil and paper. But doing the best I can. Okay, there you go. There's graphing exponential functions. All right, growth and decay. We've spent a lot of time on this. Remember this formula? T is the time in years. R is the percent as a decimal. So remember, to get R, we take the percentage, we divide it by 100, and that gives us the decimal. Okay? P is our principal. This is time, and that's in years. This is the principal or the starting amount, and this is the amount. after t years. Okay, so let me set this problem up here. A town is 12,000 people. Well, that's my principal. Its population is growing at a rate of 5.6%. Well, if I take the 5.6 divided by 100, I get 0.056, and that's R. That's what R is right there. Okay, I don't have T yet, but T is in part 1 of the problem. There's T right there. So to set this up, I'm going to go A equals 12,000 times the quantity of 1. It's growing population, so I'm going to use plus 0.056, and I'm going to raise it to the power of 4. Now hold on one second here because I forgot to bring my calculator down with me, so I'm going to get onto Google, but I'm not going to make you watch me do that. Okay, so hold on a second here. There we go. There you can see my work in Google, and I come up with this 14,922.339,582. So 14,922, I think I'm going to stick with that. Say about 14,000, what did I say, 922? Yes. Okay, 922. And that's approximate. Okay, I'm through that decimal way because I'm talking about people. All right. So what was the population 5 years ago? Very much the same problem. I'm going to do A equals 12,000. The population was still growing, so it's going to be positive. But the time is in the past, so it's to the negative 5th power. Hold on one second, and I'm going to go ahead and go to Google and get my approximate population. All right, so it looks like I have, it must be misinterpreting what oh, no, that's fine. I think I misspoke a minute ago. I said I was expecting a higher population. Of course, I should be getting a smaller population, right? Because it's growing into the 12,000. So it looks like I have 9138. So about 9,138 people. Yeah, that makes sense because today I have 12,000. In the past, I would have less because so it could grow to 12,000. Okay, here's the same type of problem. Same type of problem. Okay, this time an investment of $8,000 is losing money. That tells me that I'm going to use the minus R. 8,000 is my principal. Rate of 10.2% per year. Well, I take the 10.2, divide by 100, and I get 0.102. Okay, and that's going to be a negative in my R. T is here. So to solve it, A equals the 8,000, 1 minus 0.102, and that'll be to the 3rd power. All right, I'm going to set this one up too, and then I can do both. This one, 4 years ago, it's going to be the same exact setup, except 4 years ago will be in the past. So it'll be a negative. So I'm going to get those answers. Hold on one moment. I'll pause it. Okay, and so A ends up being approximately 57. Oh, I can remember the decimal. I can't remember the middle one. I think it's 93. It is 93. Okay, 93. So that's $5,793.21. Okay, now to do the other one, all I have to do is change the exponent to -4. So this ends up being approximately $12,032.25, and it was just a crunch problem on the calculator. Just crunch the numbers. Okay, finally, a half-life problem. So let me see here. I'm going to make a little table here. There's a half-life of 100 days, and I remember that, you know, at 0 days, there's 100%, right? Okay, and I'm going all the way down to 18 3/4%. So I'm going to need 50%, and then I'm going to need 25%, and then I'm going to need 12.5%. I'm not going to continue the table because I know 18 3/4 is between 25 and 12.5. So I'm going to 25, 12.5, add it together, and we get 37.5. Going to divide by 2. I'm taking the average, right? So that looks like it's going to go 18 times. So that'll be 36. Oops, I don't need the decimal point there. Sorry. Bring down my 5. It's going to go 7. 2 goes 10. 1875. Okay, so now um, the half-life. Now let's figure them out. 100 days. So every half is 100 days. So there's 100. And then I have 200 days. And then I'm going to do another 100 days, which will be 300 days here. Now I'm going to average the two, which is going to end up being 250 days. And there you go. So that means the half-life is the substance is 250 days old approximately. All right, that's your second review video. Hopefully you do your best because you guys deserve to do your best. And you can get some really good grades on the test. All right, Mr. Lawrence signing off. Good night, everybody.